All right, let's take a look at a topic I believe we might have already looked at this semester. Let's take a look at exponents and then eventually square roots. Now, all an exponent is, it's kind of a little number above a big number. So if we had 4 to the third, the number on the bottom is called the base. The little number up top, that is the exponent. Now, all this is this is just shorthand notation for repetitive multiplication. Now what I mean by that, if we have something like 4 to the third, that tells us to take the base, multiply it by itself the exponent number of times. So 4 to the third says take 4, multiply it by itself 3 times. Now, on this side, this is called the exponent notation. This would be the expanded notation. So if I gave you 5 squared, that says take the base 5 and multiply it by itself twice. So if we were to expand that out, that would be 5 times 5. So let me give you a couple here to see if you can do this. So, right. The exponent expanded out. So write the exponent expanded out. So let's say I gave you, I don't know, 3 to the 7th, 5 to the 3rd, 1/2 to the 4th, maybe that's a 4, and let's do 0.02 to the 3rd again. All right, so take a second, pause the video, see if you can expand those out, and then we'll pick it back up together. All right, so you had a second. Let's see if you managed to do this right. So we have 3 to the 7th power. I wrote that too big. So it says take 3, multiply it by itself 7 times. So 1, 2, 3, 4, 5, 6, and 7. So we multiplied 3 by itself 7 times. All right, 5 to the third would be what? 5 times 5 times 5. 5 times itself 3 times. And 1/2 to the 4th is, well, 1/2, 1/2, 1/2, and 1/2. And of course, 0.2 to the third would be 0.2 times 0.2 times 0.2. Okay, so that would be the expanded notation. You should also be able to go the other way. So write in exponent form. So we're going to kind of just do the opposite of what we just did. And I'm just going to write a few of these out. We'll just do a couple here. All right, see if you could write those 3 using the exponent form. Hit pause, go do that. All right, if you're back, let's see what we got. Here we have the base is 4, so we're gonna write the 4 first. And how many times do we multiply by itself? 1, 2, 3, well, 4 times. Here our base is 3, and we've multiplied 3 by itself 5 times, so the exponent would be 5. Here our base is 2/3, and we multiplied 2/3 by itself 3 times. All right, so there you go. You should be able to go from the exponent form to the expanded form, and from the expanded form to the exponent form. Now this is just expanding them out. This isn't evaluating them. By evaluating them, we actually want to come up with what a final value would be. So let's just say here if I said, that didn't look right. Spell evaluate right on your own paper. I said to evaluate this, so if I said what is 3 squared, now if you need to expand this out, that's fine. If you need to write this as 3 times 3 to get to your 9, there's nothing wrong with that. Let's say if I said 5 to the third, all right, that's gonna be a pretty big number. Hit pause, see if you can figure out what 5 to the third is. All right, so if you're back, what do we have? We'd have 5 times 5 times 5. Well, 5 times 5 is 25, and 5 25s is 125. Let's try another one. What about 3/4 squared? Again, hit pause real quick, see if you can figure that out, and then come on back. All right, so 3/4 times 3/4. We multiply fractions straight across, so we multiply across the top, that gives me 9, multiply across the bottom gives me 16. All right, what about, let's do one more of these. Let's do 2 to the 5th. Again, hit pause, see if you can figure out what that is, and when you're done, come on back and let's see if I get the answer right. All right, 2 to the 5th. Again, if you don't have to expand this out, that's fine. I'm just kind of showing this for your notes. We're multiplying 2 by itself 5 times. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 1 last 2 would be 32. All right, so here's our exponents. And I believe we've already seen this at least once this semester, so this should be a quick little review. Let's take a look at square roots now. All right, for the square root, this is called a radical. This little check mark symbol, that's a radical. Now, it's called a square root because technically, even though we don't write it because we're lazy, there's a 2 right there, and that is called the root or the index. You don't need to write that 2 there, it's understood to. We just say if you don't see a number there, we just know that it's a 2. So when we do something like this, and I said the square root of 9, this is really asking a question. It says, what times itself is 9? So the square root of 9 would be 3, because 3 times 3 is 9. All right, let's just try a few of these, because again, once you practice these, you'll end up being pretty good at them. I'm gonna write 4 or 5 down here, and let's see if you can do these. Let's see, square root of 25. All right, go. Try those 4 there. See if you can figure out what the square roots of each one of those are. All right, so let's see. Square root of 25, that says what times itself is 25? Well, the answer would be 5, right? Because 5 times 5 is 25. Square root of 36 is, well, 6, because 6 times 6 is 36. Square root of 81 is 9, because 9 times 9 is 81. And the square root of 121 would be 11, because 11 times 11 is 121. All right, make sure you're practicing these. You should know your perfect squares fairly well by now, so doing the square root shouldn't be too difficult for you.